All right, this ultimately is a limiting reactant problem. And so we have to find limiting reactant first. So is it bottles, is it caps, is it volume of beverage? We've got to figure that out. So in this first calculation here, I determined if there are 0.355 liters per bottle, I calculated the number of bottles we would need, and we need more bottles than we have. And so if we stopped there, we might think that was a limiting reactant. But if we look at the number of caps that we have, since the question says how many bottles can be filled and capped, there are fewer caps than there are bottles. And so ultimately then we determine that caps are the limiting factor. And then once we run out of caps, we're going to have beverage left over, we're going to have bottles left over. So it's caps that limits it. So we can have 1.08451 times 10 to the fifth bottles that can be capped and filled. Now, I think they're kind of arbitrarily asking for 6 significant figures here. The sig figs in this problem are a little nebulous because if we have that many bottles, that's an exact number, right? You can't have half of a bottle. So that number of bottles is an unlimited number of significant figures. And then what do we do with this 355 milliliters per bottle? Is that 3 sig figs? Is that an exact number? I'm probably going to treat that as an exact number. And so that's unlimited sig figs also. Our caps, again, we can't have half a cap. We're going to assume that is an exact number. And then our volume of the beverage is probably also an exact number. If you don't treat those as exact numbers, then maybe your liters of beverage will be your determining, or the number that determines your significant figures here at 5. Or maybe the bottle capacity might determine your sig figs at 3, depending on how you interpret the problem. But that's some of the challenge with sig figs sometimes. It's often how you interpret the given information. In part B, then, we want to find out how many bottles are left over. And we're going to express that answer to one significant figure. That's kind of arbitrary. I'm not sure, other than they want you to practice rounding to the right number of sig figs. I'm not sure why they would do that. And so if indeed we need this many bottles, as we determined in part A, this yellow part here, and the 1.26835 times 10 to the fifth, that's the number of bottles we have. We have 10,474 left over. Rounding that to 1 sig fig, we're going to get 1 times 10 to the fourth bottles. In part C, now we're finding out how much beverage is left over. Well, based on the number of bottles filled, using the 355 milliliters per bottle, we calculate the volume of beverage that we're going to need. That is less than what we originally start with, which is 48,745 liters. And so the difference between those two, that's the amount left over, 10,245 liters. And again, they're asking here for 1 sig fig, so that's going to be rounded to 1 times 10 to the fourth liters. Again, an arbitrary number of significant figures. And then the last part, well, if you were able to get parts A and B, or at least part A, then you already figured out D and E, assuming you got part A correct. In part A, we determined the limiting factor was the caps, right? That's how we determined how many bottles and capped bottles we could fill. And then so part E says which one limits the production. I hope this was helpful. I know lots of you had questions on this one. It was a little weird in my estimation in terms of sig figs, but sometimes they're just arbitrary like that.